What's up, YouTube? In today's episode, we're going to be doing part 2 of core principles of API design. As you remember, in the previous video, I said if you can design methods correctly, then you can design classes correctly. If you can design classes correctly, you can design systems correctly. And if you can design systems correctly, then you can design APIs correctly, whether it's a system API or a class API. So I'll do a little bit about just I think one aspect of method design, and then I'm going to move to class design in this episode. So, and remember, these are the core principles. It's not the full gamut of various principles or ideas you might have behind class design. These are just the core principles. So, but I left over one core principle from method design in the previous one. So I'm going to start there, and then I'm going to start with core principles of class design. All right, so one of the aspects, we talked about method arguments being sort of to the point or need to know basis from the last time. In this, what I didn't talk about was what if you have hierarchies of classes. Let's say there's a base class and some descendants, and you want to pass one or more of these descendants to a method in a class. And what if you want to return one of these hierarchies from a method? So how do you design methods that sort of take on hierarchy, especially or including collections? Immutable versus list versus an array, and so on and so forth. Collections are slightly different, but I'm going to start with the just hierarchies of classes that you may have in your system, and as one as input arguments, and then two as a return type from a method. So the rule is, in arguments coming into a method should be the least derived type. One of the principles behind arguments to methods that are in a hierarchy of some sort is that input arguments to methods should be the least derived type. Now, don't try and punch holes in this thing, as in don't say what if it's this and what if it's that. I'm saying it very simply. There's just this much to it. Least derived type. Now, if I say more, which I will, it might end up confusing you more rather than clarifying what I'm trying to say here. So I'll add on least derived type possible. So what I'm saying there really is don't try and force fit it in such a way that it's the least derived type. So in other words, if you have a hierarchy of classes, your input argument should be that of a base type. In other words, methods should be designed as per a base class rather than a specific descendant. The same goes for if you're working with collections. But I prefer to use an immutable as an input argument for collection types, because that's saying more than just, here's some interface that is, let's say at that high level, it's saying it's a read-only collection. So even though you might be sending an array to your method, or you might have a list in your hand when you're sending it to this method, when a method says it requires an immutable, it actually is saying something to you. It's saying, I don't intend to modify this collection, which is key to know, because if you're saying I want a list, it's implying that, or maybe you don't do that, but really if I see a list in a method design, I'd say, okay, so what are you doing with my list? Because you can add things to the list, you can modify, you can remove things from a list. So the message is different. And as you know, it's programming with intent, which means show me your intent. When you design classes, when you write code, show me your intent. What do you really want to do? If you're asking me for an immutable, I understand your intent to be, you don't intend to modify my collection, even though I may have an array in my hand. Conversely, if you're asking for an array, or if you're asking for a list or an iList, I'm going to be wondering, unless that's the purpose, I'm going to be wondering, like, do you really intend to modify my list? Is that why you are asking me for a list, or you don't know the principle? So you're asking for a list just because that's what you know. So for collections as well, default or start with the least derived type possible. And with collection types or an interface types, resort to an immutable if possible. Now, by possible, I mean, there's people who say, okay, well, let's say I'll ask for an immutable because, Shiv said you should get, your signature should ask for the least derived type possible. However, within the method, they actually need a list. So what they're going to do is they're going to try and cast that argument to a list and then use it as a list, which means they then tend to modify things or do something else that a list has that an Immutable does not have. And to that, I would say, don't lie to me. No, honestly, programming is not about trying to make fools of people or to, trying to swindle people out of things or trying to hack your stuff out of the way. That is not what programming is about. If you're there for that purpose, then this is not the channel that you should be watching. Even though I used to be a hacker in my last life. Besides the point, the purpose of principles, guidelines, rules, whatever you want to call these things, is you're an honest programmer. Nobody's trying to beat the system or defeat the system. So the rules are very simple, right? So least derived type is the rule. I'm just saying least derived type possible. So you kind of get a sense like, don't try and fit a square peg in a round hole. Don't lie to me by asking me for an Immutable when in fact you need a list. And so internal to your method, you're going to cast that to a list and use it. And it'll work 90% of the time because for most times, the collections that we have in our hands are a list. And so it works. And then every once in a while, it'll start blowing out and you won't know why it's happening. All right. The return types. So again, if you're working with the base class or hierarchy of your own or even with collections, and collections are slightly different in this regard. For hierarchies of your own, methods should always return the most derived type possible. I'm hoping you're understanding the least derived type. Least derived type means is going close to the base class. So typically the base class. The most derived type is going down to the specific, right? Now you must be wondering, well, if a method returns, say, a descendant, then that locks the caller into using that descendant. And I'm saying that's fine because if the caller wanted to receive from a method, there's a hierarchy of classes, A being the base class and B and C and D being descendants. I'm saying if you're working with a D within your method, the return type should be a D. The caller at the call site, when they receive the return value from your method, they can type that variable as a base type. So they can still use it polymorphically. They can still treat whatever you return, even though it's a more specific type, meaning it's a descendant, they can treat it like a base class if that's what they want. But you are working with a D, which is a more derived type within your method. Then don't return a base class. Don't make it like you're returning a base class. You return the type you are working with, and the caller can always treat your return type as a base class if they wanted to do that. All right. So that's the one rule with regard. Or with collections, I still tend to return Immutable as a collection for the same reason. I'm showing my intent. I'm saying I'm giving you something that you can only iterate over or enumerate over. You cannot modify it. Again, yes, there are ways to hack that. And I'm not interested in anyone that wants to hack it. So if I return an Immutable, I'm telling you something, then treat it as a enumerable only, read only, if you will, even though it's not inherently read only, right? There are specialized collections, read only, and immutable collections in .NET. They have a cost to them, and I'd rather not pay that cost unnecessarily when I don't need them to be completely read only, when I just trust the callers of my methods to say, I'm sending you an Immutable, so please treat it as an Immutable, and that's it, right? Why complicate the whole thing? Okay, so method design is done. Now I'm moving on to class design. Now, of course, class design, we also talk about methods there, but I've tried to keep the method-specific things separate. But of course, I can't talk about class design without talking about methods. So they are kind of overlapping there. Method design is a subset of class design, the core principles of class design. With class design, the first principle I have is all classes start their lives as internal sealed. I don't care what it is you're doing. I don't care if you know or don't know what you're doing. As in you don't know the intent of where this class is going to be, in 10 years. It doesn't matter. It starts its life as internal and sealed. What is internal? Internal implies that the class can be available only to other classes within this assembly. Classes outside this assembly will not see that class. Now, there are ways to make your internal classes visible to classes in a different assembly by choice. Specific assemblies by choice. No other assemblies will see the internals, but the ones, maybe your own assemblies, you want to share classes from one to another, but you don't want them accessible to anybody else, you can control it. But essentially, they start their lives as internal and sealed for the same reason. Sealed really means you cannot descend from this class, right? That's what it says, sealed. You don't know right now. No, honestly, you don't know right now if your class needs a descendant. Yes, exactly. Yeah, no, of course. Sometimes you know going in, this is a base class. I'm not talking about that. I'm talking about just a class. You define a class, internal, sealed, period, done. No question. Because you can always open it up. You can always make it more accessible and unsealed, if you will. But if something is more accessible initially and you cannot reduce the accessibility or you cannot seal it after the fact because somebody might have descended from it or been using it, like say from an outside assembly, and now you've just broken their stuff and they would hate you for it. So keep your classes internal and sealed and only unseal them or make them public if there's a very strong and good reason for you to do that. Conversely, if you see a class that's been sealed and internal, before you make any change to like making it public or unsealed, think really hard about what the designer of that class intended. Or their intention is pretty clear. They're saying, I don't expect you to descend from this class, and I do not want this class to be made publicly accessible. They had an idea, they had an intent. Try and understand that intent and see if it's truly invalid now. So if it is, then undo it. But if you don't know, don't just blindly make it public or unsealed. Think, because there are many classes, especially the way I design classes, I don't intend and I don't want for somebody to descend from my class. If you want to play in the same polymorphic hierarchy, descend your own. Don't descend from my class, right? Because I don't like classes to have a deep hierarchy. So as far as I'm concerned, there's a base class, there's one descendant, and that's it. There's no descendant after this, right? I can go wide hierarchies, but not deep hierarchies. So if I create a descendant from a base class, I will seal my descendant. And that's the second part. When you descend from a class, internal seal automatically, right? Just don't think about it. Just internal and seal. Just start there. You can always rethink your strategy at a later time if the need changes or you rethought your idea or design differently in the future. But as it comes to sealed, there are sort of two ways we can do that, unfortunately, in C#. You can seal at the class level and you can seal at the method level, or both. There's no real guidance from the C# team on this, specifically saying you must do it here or we prefer people do it there. I haven't really looked at their source code to see what they're doing internally, but this is what I would suggest, and this is what I do. I seal at the class level. Sealing at a class level automatically seals all methods in the class. You don't have to go individually to every method and seal it. Like every virtual method that you might have in a base class. Then when it's in a descendant, you want to seal the class. The question is, how do you seal that class? I say seal it at the class level. Now, there are some odd cases where you want to make one of the virtual methods that is unsealed, but the others to be sealed. And at that point, you're going to have to resort to sealing at the method level. But it's a very, very rare case, and I would question it as well. I would question it. So start with the sealing at the class level. No need to repeat the stuff is sealed on method level. And as well, actually, remind me of the internal. So internal is also, you can have methods that are, internal, public, and so on. The access modifiers. Again, it's the same thing. If I make the class internal, should I make the constructors internal or public? And I say, no, leave what you understand to be public. There's, again, a rare thing to have something in a method that is internal and then there are other methods that are public. So the fact that the class is accessible only to classes in the assemblies, then that's an internal. But you make that or mark the class as internal at the class level, not at the method level. And constructors and other methods that you intend to be public, they're still public, as in they have the access modifier public, but they are not public in the sense that they cannot be accessed from outside the assembly. So at the class level, you can control it, and therefore at the method level, you're not modifying the access modifier at the method level. So methods should still be public and private protected. Don't go making it both on both ends, meaning internal classes and then internal methods also. And that'll just be too much, because when you want to make a change, it's just going to make a nightmare. And there's no reason to say the same thing twice, personally, I don't think. And again, there's only one case in which I would have a internal constructor and a public constructor, right? But that's just that one oddity that I have, and I'm not going to go into details here, but that's kind of the only time I have a public method a constructor and an internal constructor where my class might be internal, right? Basically, even what I'm saying is a public method in a class, even though the class may be marked the sealed, might be sealed. Methods level, you're thinking as, do I want somebody outside the class to access this method? Not so much outside this assembly, right? So if you expect somebody to go to construct an instance of a class, then the constructor needs to be public. Whether that something is inside this assembly or not is controlled at the class level by marking the class internal or public. All right, so that takes care of the internal and sealed, both for at the class level, at the method level, constructors, etc. All right, that's the simple part. All methods besides the constructor, of course, if in case you do plan to have somebody construct an instance of your class. It's not required, right? Because you can have an abstract base class whose constructor is protected. It's not going to be constructed, so that it doesn't need to be public. It should be protected. And then descendants can make that class, their method, the constructor is public, because you can make things more accessible in a descendant. You can't make it less accessible in a descendant. So methods should start their lives as private. What I mean by that is all methods, instead of saying public void, make it private void. Just get in the habit of these things. Even when you define your classes, is saying public class, make it internal sealed class. Simple. You can even modify in Visual Studio the template. When you say find new class, it'll be internal sealed class. So, which is what I do. I modify the template. What would they call it? Yeah, I think it's called a template. So when you define a method, private void of whatever the return type is, rather than public. Get in the habit of doing that. Methods start their lives as private. If you have a virtual method, or if you have a need. So let's say I'm designing this class, and typically I'm going to talk about the base class, but it applies anywhere, this rule about the virtual methods. And in my mind, I'm saying, okay, here's this method, and I would like to make this method virtual in the base class, but it's public. The guideline says, this is the .NET Framework Design Guidelines, due to security, is they're saying, don't mark public methods virtual, right? But in your head, you would like that method to be virtual. So what they're saying is define another method. So let's say your class is called, the method is called do something. And you would like that public method to be virtual. In your head, in the way you're designing the class, you're saying this method would be virtual. The guideline says don't make the public method virtual. So what you're going to do is you're going to define another method that is protected. Same named method with the suffix of core. So the method is called do something. Then this protected method will be called do something core. Right? The suffix of core. That method will be virtual or abstract, depending on what your implementation is. And the public method will simply call this virtual method or abstract method, right? So the guideline says don't make public methods virtual, but you should have a same named method that is protected, abstract or virtual, with the suffix of core, and then you just call it. If it's returning something as well, you just return it all the way back out through the public method, right? So that's all you got to do. Nothing big about that. And also, as you build out your system, people in your team will get kind of used to the idea. Oh, there's a core method, so I know there's a pattern, so you know like what to expect. That there's another method that's public that's calling this method. All right. So the next one I think is maybe it'll take some of you by surprise. This is just something I do, and I've developed this idea or this concept over the years. And I've been doing this for years as well, but it sort of gradually occurred to me that there are some things I need to do or check off and follow as a guiding principle. And I've been doing that for many years. It's paid off big time. And that's this. 1. I hardly ever use non-static classes. You knew that was coming, right? That had to be something. Okay, let me state it differently. I only use instances of classes when I have the need for polymorphism. If I don't have the need for polymorphism, then those classes are not only not in a hierarchy, they're not even an instance, meaning they're static. Okay, I'm going to talk about another principle and then we'll kind of tie it up both together. I also have two kinds of classes. There's classes that are DTOs or data transfer objects, or some people call them value objects. And then there are classes that do stuff, the behavioral classes, the classes that actually get some work done. The DTOs only hold properties. Those classes have no behavior. They're simple holders of properties. These are immutable classes. So DTOs are immutable, as in you cannot modify the properties once you constructed the class. So once you have an instance in your hand, the properties cannot be changed. And you want to start there. Always start there. It's very tempting to make your life easier to make something that's modifiable. But if you need to modify it, create a new instance with the properties from the previous instance and the changed properties that you wanted, for the new instance, and send that out as a, let's say implementation of your method. Don't modify DTOs and their properties. So make them immutable. And they're typically public because they're going in and out of your system. Let's say, at your API level, you're surfacing this DTO as an incoming argument or as a return type. So they're typically public and they're sealed. So even though they're not internal, they're public and sealed. Typically, they could be internal and sealed, but since they're typically part of your API from, let's say, a web API endpoint perspective, they can't be internal. They got to be public, but they should be sealed to indicate you don't expect to create a descendant. And please don't create descendants of DTOs. I know it's very tempting. You got these two classes, they kind of share the same number of properties, doesn't matter. They don't belong in a hierarchy. Right? Just keep them separate. It's not going to cost you anything. It's not going to help you either ways, but it might cause you a lot of pain if they're on a hierarchy and then you start getting these really deep hierarchies and this gets really gnarly and nasty. So don't do that. Okay, so we talked about these two ideas. One is there are classes that are DTOs or value objects that are immutable and sealed, and most times public. And then there are classes that have the behavior, right? So the DTOs have properties only and zero methods. The behavioral classes have methods only and no properties. These behavioral classes are typically static and stateless because they have no properties. They're completely stateless. If you don't understand statics, please take a look at one of the videos. I go into detail about statics. Statics they could cause you trouble if you don't understand what they are and how they work. And then next, weird data stuff is happening in your systems, and it seems like data is being shared across, let's say, different users in your system at the same time, and it can get pretty hairy if you don't understand statics. So don't use statics unless you really know how they work. And statics also should have no state. So I've got, again, two types of classes: the behavioral classes that are no properties but have methods. They have zero state. They're stateless. And then there are DTOs that have no methods, but only properties, and they're immutable, sealed, typically public. Get that? I won't go into the details of why that is the case. But if you can sort of extrapolate in a larger system, the kinds of things that occur, the classes that do the work should not be maintaining state, and they have no need for properties. And I'm being, of course, there may be times we have these properties. Those properties are also stateless. Let's say class A depends on some other behavioral class B and another behavioral class C. So I'm not going to inject the dependencies, as always. I mean, if you don't know why I wouldn't do that, check out my dependency injection video. But this class A has another class that helps it do some behavior. So there's a B, and another class C that also does some behavior. So these are behavioral classes. I might have B and C as properties internal to the class, not public, as properties. But when I say stateless, I don't just mean, oh, there's a property stateless. It's not stateless, and otherwise it is. So it's not that simple. If what I'm storing as a property is it's also stateless. The class that every one of my classes is stateless. Therefore, even if there's a property of class B and a property of type class C, that's fine. Those classes are also stateless. So it doesn't really matter. It's not like there's something, untoward or weird is going to happen. So when I say they're stateless, it's not necessarily based around a property. It's the idea of and the concept of statelessness. Behavioral classes are stateless. That's not to say they don't have properties, but everything about them is stateless, and the properties, the classes for which they have properties are also stateless, and so on and so forth. So the whole chain is stateless. Like it's not like suddenly somewhere someone does something that's stateful. So there's a kind of clear distinction, but a very disciplined paradigm in the way you develop your applications. The details are like that. They have only state and they're immutable and they have zero behavior and they're sealed and they're public typically. And the behavior classes are typically stateless, no properties, no state. Let me just say it that way. It's not that there's no properties but no state. But of course, properties can imply state, but not always. If you don't understand these things, you need to get very clear about what statelessness is and how or when you could start to introduce state unknowingly into a class or not before you start going down this path. And these behavior classes, unless I need an instance, see details I need instances because I could have two customers at the same time in my hand, so there are two different instances of two different customers, but there's properties only and they're immutable. But I will have instances for that. Behavior classes are very rarely, I need instances where because they're stateless, it doesn't really matter whether they have instances or not. Now, there are times when some behavior classes do require instances for some complicated reasons. But for the most part, you're not dealing with state within these behavior classes. Therefore, the need to have instances of classes that have behavior also kind of gets negated. And so it's not really required. But that's what I would do for my behavior classes. They'd be stateless. They'd be typically static for the most part. Sometimes they'd have instances. And there are things that might drive that if they need to be instances. But mainly I have instances of classes when I'm using polymorphism. Or let me put it this way. Because I'm using polymorphism, I need to have instances. When I'm not using polymorphism, I'm not interested in having instances of classes that have no real purpose being an instance. They do just as well with statics. Right? I'm going to talk a little bit about implementation of methods now. So even though it's not sort of part of that API, it's just something I think you should be aware of. And so there's two parts to it. One is every public method of your classes should do orchestration. What does that mean? There's a class that says I'm doing this. But the doing this is not generally a simple thing. It could be involved 3, 4, 5 steps. So think of it as steps. In order to do this thing, I need to first do this, then do that, and then do that. And I call that orchestration. Public methods of classes should simply just call other methods the other steps. All right? You're always trying to show the sort of the reader of the code. If I'm doing the code review or somebody joins the team new, you're trying to explain to them what it is you're doing, not how. I don't want to get into the weeds of how something is being done. If this method says it's doing this, I'm not interested to know how it's being done. I want to know what is being done. Sorry, yeah, I confuse myself. I want to know what and not the how, right? And the way you get there, you're saying, I'm going to orchestrate. Every method is going to be broken down into steps. And every step is a method call. So I'm hardly ever seeing the how something is being done. I'm only seeing what is being done. And that's key to making systems and code understandable. And it ties in perfectly with levels of abstraction. Now, this is a pretty deep topic. It's not something I'm going to go into over here in this video, but I'll give you a brief and you'll understand hopefully how that works. I'm going to do some of my hand wavy here, so that hopefully that'll help. All right. So in my mind, if there's a class, it's at a certain level, and this level is like a vertical line, right? So we have layers that go horizontally like this. There's let's say from your end, it'll be the UI, the business layer, the data layer. Right? So it goes from here to here to here. And I'll be putting that up there. Okay, you may see a diagram or something that's just going like that. But within each layer, since there's so many classes in there, in my mind, I'm putting, it's not actually in my mind, actually, it manifests itself in the Visual Studio solution as well. There are levels. So there's a class at a certain level, and classes at a certain level will be at a certain folder, physical folder level as well. Now, they don't all have to be in the same folder, but from the root of your project, you can have multiple classes that are one level down from the root. Those classes are at the same level, right? Then classes that they use or depend on are one level down from that in another folder. So these levels are physically manifested in the folder structure on the file system. And of course, in Visual Studio and your Solution Explorer, you'll actually see that, right? What are these levels doing? These are levels of abstraction, meaning a class at a higher level is doing things at a higher level. In other words, it's almost like your manager and you, or if let's see there's a manager and there's a team lead and then there's you, right? The manager, they talk about hand waving, right? They don't actually do anything. They just delegate, which is their job. But that's what I mean. Orchestration is like saying, hey, you're delegating. They're not actually doing it. They're saying, okay, you do this, you do that, you do that, and come back to me when you're done. All right, and this come back to me actually is important. That's another aspect I'm going to talk about with regards to implementation of the methods, but it's part of the design, if you will, from an API standpoint. Or at least class design standpoint. It may not be public methods, but they're certainly parts of the class design, core principles of class design. So methods at a certain level can only call methods that are one step lower than them. Right? They can't call methods that are more than one step lower. And they cannot call classes or methods that are at their own level of abstraction. In other words, if a class is calling another method in itself, then that other method is potentially at a lower level of abstraction. If they're at the same level of abstraction, it doesn't make sense. So there's something going wrong in the way you're implementing your classes because you're not able to understand that, okay, when I'm at this method, I'm at this level of abstraction. I'm kind of just doing the orchestration. And then I've got a bunch of code in the same method that's getting into, HTTP client and what God knows what else, right? That is too low level of an abstraction. You're mixing things up in a method. So you need to split it up, right? That detail level file operation or a for each loop or call out to, some web service using HTTP client, that is way too detailed for, let's say, a class at a higher level. So if you have a method that's got is calling out to two methods and then it's doing some kind of work there, that's too detailed a level of abstraction. So that part has to be refactored out into another method or another class, depending on what your design is. But the levels of abstraction will be seen in code where you can say, okay, I'm getting now into the minutia of how something is actually being done, not the what. All right. So when you find yourselves having to write code that does the how part, it can't also be mixed in with code that does the what part. Right. So the what and the hows need to be differentiated. And typically, at most, you have 2 and sometimes 3 levels of abstraction. Right. You don't want 7 levels of abstraction. Actually, that's not what you want to do. And you also don't want this coming back I was talking about earlier. If A calls B and B calls C, that call has to just go back to A, right? You don't want to say, I'm going to do this, that calls another class that does it, another class that does it, something else does it. And now you lost track of whoa, what's going on? Where's this going on? It's not coming back. In other words, if you were to design the flow of your system, rather than saying this one class first calls this one, then calls this one, then calls that one. So this one class is orchestrating across maybe 2-3 classes. You're not losing track of what is going on. Probably put a diagram up here so you can visualize my hand waving. Can you see all that? All right. The idea is that when you're orchestrating, it's saying, okay, you go to this, you go to this, you go to that. You can come back to me when you're done. And then I'll do something else. Once you give me all the results, I'll do something else. I'm orchestrating. Those classes themselves are potentially also orchestrating. So if all classes are orchestrating, then you're not doing this chained flow kind of thing. It's each class is taking their functionality, breaking it down into some abstractions, and then saying, okay, I'm not going to do these parts. I'm going to have other classes. I'm going to call those classes. So it's always breaking down from orchestration to a final level of detail. Now, sometimes you might go from orchestration in a public method to some level of details in protected or private methods in the same class, which is fine. But if you are breaking things down two other classes, or even within the same class. But within the same class, it's difficult to see in terms of that level of abstraction. But typically, methods classes should also not be doing mixed levels of things. You can't have a manager, for example, and I'm talking about like your manager, at work, saying, okay, hey, Shiv, go write this code here, and then the manager also starts to write code, right? In other words, the manager is delegating or orchestrating and also implementing. So they're doing the how versus the what part, and they're doing both in this case. You don't want classes that kind of do both things. So classes are typically doing orchestration, and then there'll be maybe 2, maximum 3 levels deep in your system, the class that actually does the thing. Right? So at that point, it's not deciding why you want to get it done. It's just doing it, and therefore somebody has called it to get it done. It's not deciding whether it should be doing it or not. It's doing it because it's been just told to do it. So you want to break down your classes and the methods by way of levels of abstraction. And typically it also manifests itself in terms of folder structures where class A is calling B. The fact that class A is calling B implies that class A is at a higher level of abstraction than class B is. And it has to be found in a subfolder of the same folder from wherever class A is. At least that's how I design. So it does physically manifest itself on the file system and solution explorer. So if I'm wondering, where is this class B? I already know it can only be in this folder here. It can't be somewhere else. It's here. Classes and classes in the same folder, so siblings, don't talk to each other. Methods at the same level of abstraction also don't talk to each other. There's something funny going on with the way you design that class. Right? There's an abstraction problem. They're not being abstracted correctly. So you got to be careful about that. So levels of abstraction by way of folder structure, also by way of methods in the same class. You can have, I'm not saying you should have a clutter of classes just because you're at different levels of abstraction. If you only want one class in your system to do all of it, that's fine. As long as there's not a mix of implementation and delegation in the same method. Right? That's something wrong with that, the implementation there. So if you have methods that do, then those methods only do. They don't orchestrate and do. All the doing should be done to one method, and all the orchestration should be done in a different method. So that way you're not mixing up the levels of abstraction. And the classes become a lot easier to understand. And there are many times I'm debugging and I'm not interested in the how are you doing it. I just want to know what is being done. So I can easily just step over that method and start having dug into that. And next thing you know, I'm in a loop with a million iterations that I wasn't intending to go there. So it makes your debugging lives easier as well. Right? So that's another benefit of thinking about levels of abstraction and having a physical manifestation of that whole idea in your folder system, and also that classes in the same folder, the siblings don't talk to each other, and they can only talk one level down. They can't talk 2 levels down. All right, keep that all of this. I know it's a lot to digest here, but it is intense. But the thing is, once you implement these systems in this fashion, they're easy to maintain, they're simple to understand, and they perform super well. Of course, I can't speak to how you implement, since I'm not talking about real implementation of code yet, but that's kind of like, it becomes easy to maintain and understand the system when you join a team. They say, when they're halfway through the building of that system, or even at the end of the building of the system, they're just easy to maintain. So I think this brings us to the end of the part 2 of core principles of API design. And in this specific case, class design with a little bit of method design. If you think I've said something that is like, really? Please ask me in the comments. If you think, man, I never thought of that, please let me know that also in the comments. So if you have any questions, if you've got any surprises in either this video or the other video, let me know in the comments. We can have another discussion, or maybe I need to explain myself a little better in case you're not following along or don't agree with it. Either way, just let me know in the comments and I'll try and answer those questions. And thank you for watching. Please subscribe. Please hit the notify button, and I will see you next time.